Hello, welcome to another of my video. This video is pretty interesting because there I showed the two type of PCB etchants that I could use. The first one is Cuppric chloride. The second one is Ferric chloride. If you notice the word, it's really all very interesting. They all end in IC, means egg. The atom of the metal in their highest oxidation state possible. Copper can be in its 1+ form, or it can be in its 2+ form. We often see copper in its 2+ form, rather see it in its 1+ form. And here is the iron. We can see both of them in its 2+ or 3+ form. Ferrous or ferric. The ferrous chloride looks much more beautiful than the ferric one, since ferric one looks dirty brown, whereas the copper in its 1+ form looks uglier than its 2+ form. So for the etchant of the choice, I think Cuppric chloride work great, or copper 2+ chloride. Another thing about copper 2+ chloride is that once you made a lot of etching, the solution is still really pure. You can add a little bit more of hydrochloric acid, the weak one, the solution, with a bit of peroxide, or you can just simply add air and let air itself do the oxidation job to get it back onto its Cuppric form. And if you want to get the copper out from the solution, you can use simple electrolysis. Whereas this one, to refine the copper out from the solution of ferrous and ferric chloride mixture, it is a bit harder, since there is a lot of impurities of iron. Which will do the electrolysis, the iron will also get reduced along with copper. To get them out, I guess you also have to do some neutralization reactions, which I more prefer using Cuppric chloride. Also, Cuppric just looks much more beautiful, as you can see the color comparisons. If I have a filter or a prism, or known as the split filter, which can split light into its spectrums, we can use the absorb spectrum to tell the exact metal is present. Since each metal is unique, it will absorb a special wavelength of light. Here I have a really good quality LED. Shine it through the ferric chloride, you can see the color is an amberish color, which you can see from a lot of amber glass bottle. It contains the iron impurities to absorb the UV. It's the exact same color here. And the color is shifted a little bit with the halide ions compared to using a sulfate ions. But it's still really close, the colors, with the sulfate comparisons. But sulfate, it just sticks more towards shift blue spectrum compared to the chloride. Chloride shifted towards the red spectrum, which give you a sort of greenish bluish color. But both spectrum can't pass through at the same time, as we can show here. The two solution does not show because most of the spectrum is blocked off. And that's it. Really interesting about the two metal chloride etchants. And that's it. Thanks for watching.